Young people, welcome back. B&B in the house, bearded math brother. Let's get it. Textbook objective. It says, now, students are going to recognize arithmetic sequence. Also, students are going to relate arithmetic sequences to linear functions. Students will be able to write arithmetic sequences and recognize them in linear functions or in equations. Concept, again, I'd say linear equations, linear functions, but more directly, your concept as it's arithmetic sequences and identifying, finding them. Guys, let's go. Boom. So guys, I am going to start off by just, as you see the handout, it's in the middle. Let's get it out of here pretty soon. This is definitely one of those lessons that as I look at the handout and I explain to my viewers, not the most useful in an Algebra 1 course. Definitely in the textbook, but I'll be honest, guys, there's a lot more interesting algebra that you'll cover. So, not a power standard. And as you can already see, guys, I've gotten started. What's happening, they're counting by, adding 3 to each number. So determine whether each sequence is a arithmetic sequence, right? Yes or no, and explain. So I'm explaining in the boxes, guys. Yes, it's a pattern or arithmetic sequence, 4, 7, 9, 12, and it'll be, the next number. So yes, they're adding 3. But the next one, I'm going to go yes as well, because every number, they're subtracting 2. So in this case, starting with the number, you would just subtract 2 and you get the next number. So I'm explaining it by saying 15 minus 2, 13 minus 2, 11 minus 2, 9 minus 2, 7 minus 2, 5 minus 2, and even when you get to negative, you would have negative. So in number 3, it looks like 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16. So 16 plus 3, I can tell you the next number in the sequence. So yes, add 3. And don't let the negatives get you. So looks like I'm adding 1, and then I'm adding 2. Hold up, and then I'm adding 2 again. So I'm gonna have to say no, because after the first one, it changed to a different it changed to a different value that I'm adding. So can't say add 1, then add 2. It has to be add 1, add 1, add 1. So big fat no. Over here, add 2, because the negative is getting bigger. Getting bigger, getting bigger, getting bigger. So it keeps increasing, and it increases by 2 each time. So I'm going to say yes. And again, how I like to explain that, I say add 2. Now, trust me, there's somebody else saying, you know what, that B&B can't explain things. Well, you can do a better job. Someone can always do a better job. Oh, I take that. I want people to start getting at me in the chat or in the comments about that. Subtracting 3, so yes, minus 3. And guys, we got 2 more before I decide to move on. So for number 7, 10, 15, 25, 40, what? 10, 15, that's plus 5. And then 15 and 25 is plus 10. And then 25 to 40, that's what? Plus 15? So nah, man, it's got to be the same. For our last one, looks like add 5, add 5, add 5. Oh, no way. But yes, and of course, add 5. That's the rule. That's how I'm explaining it. And when I say rule, guys, later on, we're definitely going to see some, what I like to call big boy algebra. It's just a lot of variables, a lot of things that doesn't look familiar to the eye if this is something that you're learning for the first time. And here we go, guys. So now we're actually going to find the next 3 terms. So back in the day, this used to call patterns. Now it's an arithmetic sequence. And it looks like we're adding 4. And it looks like 15 plus 4 would be 19. And then 19 plus 4 would be 23. And then, of course, 23 plus 4 would be 27. And I believe I don't have to do anything else after that. And if that's the case, give me a box. And give me a box. You moved on. Anyway. of like, give me a beat, give me a beat. He already had the music going, y'all. Don't worry. Sometimes we got to remind him that we all good today. Number 11, adding 2. So no problems with my integers here. -5 into -3 into -1, and again just 5. Just 3. Number 12. What's happening here? It looks like the number's getting smaller. So I gotta subtract. And of course, even if your brain goes 2 plus 3 is 5, 5 plus 3 is 8. Mentally, you know it's getting smaller, so I subtract and not add 3. Number 13, looks like 5. It looks like I got tired of putting little operations. So 39, 44, 45. I don't know, that ain't right. That's what I get for not putting it right. Because how I go from 39 to 44 to 45. Definitely do not do that. Do it right. Moving on to 15, as you can tell, I've kind of decided that this is easy and I'm gonna go so fast I make a mistake. Any mistakes there? Nope. Adding $2.50 to each one and look good. And for number 14, looks like they subtracted. And looks like for 16, the decimals want to get you. But it looks like 3.1, 4.1, 5.1. Yeah, not going to get me there. You got me somewhere else, but you didn't get me there. And guys, boom, bang, pow. Get it out of here. And let's get something else with you. All right. You know me. Here we go, guys. So nothing's changing except they're making it more challenging. Write an equation for the nth term of each arithmetic sequence, then graph the first 5 terms of the sequence. So we're graphing the numbers that we get. Now, the fun way was what we did last time, just finding what you see and using what you know. I know they're adding 6 to get the next number. So 25 plus 6, come on now, give it to me. Wait. Oh, I gotta graph those numbers and graph my new numbers? Or I need to do what? Write an equation for the nth term. So this is what I mean by earlier. This is what I meant earlier when I said we're gonna get a little bit more challenging. If this is a formula that is like Japanese or Spanish or Russian or German, you can't read it, it's okay. Slow down. Matter of fact, pause, and let's get a little clarity. The clarity is that formula is going to answer the question for me. The nth term, meaning any term, the 4th one, the 5th one, because you know, if I were to ask you to count by 5s, go. Stop. What number did you get to? 35? Okay. Which one is that? Well, that's the 7th number. 5, 10, 15, 20, 25, 30, 35. It's the 7th number in your sequence. So the nth number. All right, we got that, right? Was it the 2nd number, the 3rd number, the 1st number, right? So, and the D, all of that, guys, you gotta go, and I'm gonna pop it in, my editor's gonna take care of this for us. The formula is critical, but as we do the first one, we do the second one and third one, you're gonna see how easy it is to plug in. We're gonna do distributive property, we're gonna do a little adding, and it'll be good. But when you see a formula like that, you have to slow down and say, okay, let me make sure I know what every single one of these things represent, because otherwise I'm just looking at something I cannot understand. Let's get back into it. All right, guys, so as you can see now, the sequence is equal to, so when I say the sequence, it can be any number in the sequence. The first number, which in this case is 7, that's why it's got a little 1 at the bottom, plus whatever number we're talking about, the 7th number, the 8th number in the sequence, the 5th number in the sequence, minus 1 times what's happening. What do you mean what's happening? Well, how do we get this sequence? Well, we're adding 6. So, put 6, and that's it. Doesn't get hard. Just what goes where. You got to keep a variable, guys, because it is algebra. There's always going to be some letters in our math. But 7 plus 6n minus 6. And of course, I can collect like terms with the 7 and the -6. And now I'm just going to get 6n minus 1. And guys, that is literally what you plug in to find out the value of the number sequence you're looking for. Okay, that made no sense. It's okay. But then they say, then graph the first 5 terms of the sequence. So they've only given us what? 7, 13, 19, 25. That's 4 terms. So we need the 5th term. So I can plug in and get the 5th term. Or let's graph and see, or just get it by adding 6. But to do the question correctly, write an equation. Guess what? There's my equation. And there's my bell telling me I can leave. No, we can't leave. You guys know Mr. Craft loves it because the bell means we're working, or it means we're done working, or it means we got more work to do, and we got more work to do. So, I boxed them both, no big deal. What I really think I'm going to be doing now, though, guys, is graphing the points. So you see my first one. First number is 7, so 10, 9, 8, 7, a little below. Next number is 13, so not quite halfway, hopefully, but you kind of get it. And then 19 below the 20. 25 I can actually hit because that's on there. And then, of course, what's next? Add 6, so 31. Looks good to me, guys. So you should have 5 points because they want you to then graph the first 5 terms of the sequence. 1, 2, 3, 4, and 5. Go ahead and get yourself a straight edge. I'm gonna go ahead and get my straight edge. And the straight edge, again, guys, is critical. And it looks like I'm not doing a straight edge. So ignore what I said about straight edge. We're starting off by graphing the points first this time. We got 30 for the first number. 26, 22, 18. So what's happening? We're subtracting 4 from the number before. So the next number will be 14, then 10, then 6, then 2. And I can just keep plotting those points as I go. But it does not give me an equation. So with me getting the rest of the values, I did more than 5. I understand what I'm doing, so why not do more? Always a good thing to do when you're dealing with your education. It's always a good thing to do. Do more. It's for your own good. It's for your education. But let's go ahead and make sure we've got this component down where, again, we're going to start with our formula. Arithmetic sequence is equal to, the nth term is equal to 30, my first number, plus the quantity of the number I'm worried about, which one, right? Minus 1 times the rule. What's happening this time? Well, we're subtracting 4, so got to be a negative 4. Not positive because we're not adding, we're subtracting. So adding a negative is subtracting. Again, guys, distributive property. We've already covered multi-steps. Hopefully this isn't something that's bothering you. Keeping the 30, we're going to get a negative 4 in. And I use the parentheses because I already put my plus sign. And then, of course, a positive 4. I use parentheses because I used it already. And simplify it out. You got 30 plus 4, of course. And I don't have a problem at all with negative 4 and plus 34. And again, that is the equation to find all my students in their seats. Of course they are, because you're here with me and you're working on this. BMB, helping you out. All right, guys, I'm erasing the other one. One of the things I was thinking about doing was plugging in and making sure that 5th number is 14, that 6th number is 10, so on and so on. Try that on your own, but let's go ahead and knock out 19 in the next few numbers because I easily see, let's just add 3. Negative 7 plus 3, negative 4. Negative 4 plus 3 is negative 1. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. So the rule is to add 3. That is what I'm going to put on the end of the parentheses when I set up to write the equation. Or am I going to graph my points first? Which one am I going to do? I was told not to move my hands too fast. Which one am I going to do? Let's see. We got it, guys. So negative 7 again, that's the first number. And again, I'm kind of making sure it's where it's supposed to be because it counts by 2s. 2, 4, 6, 8. So 7 would be in the middle. Negative 4 is right there. And negative 1 is in the middle. Easy to find 2. Easy to find 5. And again, guys, it's a straight line. looks straight to me, and I don't need to connect those dots because we're not talking about a linear equation or a linear function. We're talking about values. So I got my values, but more importantly, let's get our equation. Here we go. The arithmetic sequence is equal to -7. Now, even though -7 plus, okay, gotta be pretty, I guess. -7 plus the quantity of the nth number minus 1 times our rule, which is to add 3. So I don't put plus 3, it's just a positive 3. Get my distributive property in, and of course, boom, bang, pow. -7 plus 3n minus 3. When I collect those like terms, I'm gonna get -10. So 3n plus 10. I'm sorry, 3n minus 10. And again, guys, if I was to plug in 5, the fifth number, which I get 5, 3 times 5 is 15, 15 minus 10 is 5. I'll say that again. If I plug in the fifth number, which was 5, 3 times 5 is 15, 15 minus 10 is 5. All right, guys, looks like got some video downloading. Love it, because most of y'all probably been downloading like crazy because you've been quarantined like crazy. So, Brian is downloading episodes of his favorite TV show to play on his personal media device. The cost to download 1 episode is $1.99. The cost to download 2 episodes is $3.98. The cost to download 3 episodes is $5.97. Write a function. A function? So you didn't say equation, so a function. Write a function to represent the arithmetic sequence. Got it. Basically do what I've been doing. All right, well, I need the numbers. First number, I believe, is $1.99 because that's the first episode. So $1.99. Second number, $3.98. Can you see how that first 9 looks so much better than that second 9? And that third 9 and the $3.98. And I got a fourth 9 with a little tail. Man, DMB, get consistent with your 9s. All right, so how did I get from the first number to the second number? Well, of course, I had to add. What did I add? You know, this is probably me using a calculator right now. The next one, how to get from $3.98 to $5.97? Well, I had to add. So I see a pattern. I see how the sequence is being affected. We're adding $1.99. So the first value, $1.99, plus the quantity of n minus 1 times what's happening in the sequence, which is adding $1.99. Again, a positive. Hopefully you had a calculator handy, because if you need it, you should use it. So I'm going to get $1.99 minus $1.99, but here's where we get that funky. You see what I see? I see a positive $1.99, and I see a negative $1.99. What happens with a positive and a negative? They cancel each other. So this is one situation that didn't happen before, where it kind of looks like last lesson, direct variation. But it's a sequence. So we're going to leave it at that, guys. And I'm going to thank you for hanging with me once again. And I'm going to go ahead and leave you with Feliz Navidad.